Hello, this is Brian, and I'm here to demonstrate some of the discrete probability calculators that are part of the StatPowers website. There are, let's see how many. At the moment, 6 named distributions are part of it. Maybe more would be added later, but probably for an introductory statistics course, you would only need to use binomial and maybe Poisson uniform. But the others are there because they are sometimes mentioned in introductory stats textbooks, so you can play with them as well. But anyway, they're all pretty much the same insofar as how you use them. So let's look at a binomial distribution calculator. First off, you have the probability chart. And if you wanted to download the picture, there's a little button in the corner, download image. Click it, you get the file just downloads, and it's called mass function. The parameters are down below it. For a binomial distribution, you have 2 parameters: the number of trials and the probability of success. So let's say I actually am modeling somebody who is shooting baskets, and they are going to try 15 times, and they make their baskets about 82% of the time. So we're going to look at how many baskets they're going to make. Every time you update a field and click out of it, it's going to update the distribution. So you can see what my probability distribution looks like here, this mass function, and I can now calculate probability. The probability that the person makes, say, at least 12 shots, 12 or more. I'll put in a 12 there, and you can see what's highlighted in the chart matches what I'm describing here. The probability is calculated below. In fact, I also get the expected value, the variance, standard deviation of the distribution. I can look at the probability less than, that's pretty low. The probability that they make, say, less than 10 or fewer baskets can be found easily. The probability they make somewhere between, let's say, 11 and 14 inclusive, and then you can get tail probabilities as well. So that's how those are the probability calculation features for any of the discrete distributions. I'm going to show you also how you can sample from a binomial distribution. Let's say I want to just let's simulate this with, say, 3 people shooting baskets, and let's just do a single sample of size 3. So 3 basketball players, each one is going to have an 82% chance of making a basket, and they each shoot 15 times. Let's sample. Wow, they all make 11 baskets. That happens sometimes. Let's sample again. 10, 12, and 13. Okay, so every time you do it, it's going to be different. Let's have a sample size of 10 just to get some more numbers in it. Okay, so you can also, and if you want to do a demonstration of the central limit theorem, perhaps you might do something with the sample means. So sample mean is calculated for me after I do a sample. I can do, let's say, 10 samples of size, let's say size 35. Anyway, just want to show you, I'm getting now large samples. You can scroll and see each line, and then the sample means are found. So I have all those sample means. Okay. All of the discrete probability distributions are going to look pretty much the same. Here's the uniform distribution, the geometric distribution, the Poisson distribution, hypergeometric distribution, the negative binomial distribution. You just enter the parameters and you calculate probabilities. That's all you can do. That's what you do. Okay, well, that's everything that I wanted to show you as far as the discrete probability distribution calculator goes. I will talk to you later. Bye.